Working with built-in Java classes part 2. So here we're going to talk about typecasting among between objects. So in our previous presentation yesterday, we talked about typecasting between primitive types. Here we're going to talk about typecasting between objects. We'll talk about the concept of primitive type versus wrapper type. Yeah, we know what primitive type is. That is a corresponding object type for each of those 8 primitive types, and they are called wrapper types. And we'll talk about how we can compare objects using equal and not equal operators. And we're going to see the getClass method of object class. So object class is the root class of all classes in Java, and so object class has a getClass method, so you can find out what is a class of a particular object. And you'll also see the usage of instance of operator. This is used to check the type of your object. Okay. All right. So if you don't understand what I'm talking about, don't worry about it. That's what we are going to cover in this presentation. Let's talk about typecasting between object types. Okay, so what is typecasting? It's a mapping type of an object to another type. Okay, so we touched upon casting primitives already, and oh, wait a minute. Yeah, it looks like we're going to actually talk about primitive typecasting in this presentation, and we'll talk about the casting objects in another presentation, because we need to have an understanding on Java inheritance. Okay? So I misled you a little bit in the previous slide. So casting primitives. So casting between primitives enables you to convert the value of one data from one primitive type to another primitive type. There are 2 different types of casting. One is called implicit casting, and the other is explicit casting. Okay, so let's talk about implicit casting of primitive types first. So suppose we have the variable called numInt, which is int type. So here we define int type here, and we want to assign this int type variable to double type variable called numDouble. So we are going to assign numInt to numDouble. And here, this is actually happening implicitly because you are assigning smaller size of value to larger size of value. If you remember, int is 16-bit and the double is 32-bit. Yeah, I think that's correct. Okay. So there is no possibility of loss of information. Okay, so because you are fitting smaller thing into a larger thing, so there is no loss of information. So because there is no possibility of loss of information, Java compiler allows this one for you. So this is implicit casting, and it works fine. Okay, so this is implicit casting. Now, so this is another example. So here we have int 1, int 2, and when we divide these 2 int, then now we are mapping into double type, right? So in this case, again, there is no loss of information. This is int type, which is smaller than double type, which is larger. So we are assigning smaller thing to a larger thing, so there is no loss of information possibility. So this is, again, is allowed. Okay? So this is implicit casting. However, if you go the other way around, if you're trying to map double type value to int type value, you are trying to fit larger size of value into smaller size of value, right? 32-bit to 16-bit, right? Then there could be a possibility of loss of information. If int type, if the double is 32-bit, and if you try to split into int, there is a possibility the loss of information. So Java compiler wants to make sure that you know what you're doing in this case. So the way that it forces you to indicate to the compiler that you know what you're doing is explicit casting. So you're going to specify the type like this. Okay. So example is like this. So if we are fitting double size to int size, meaning we are trying to convert double type to int type, without this casting, Java compiler will not allow it. Okay, so Java compiler wants to make sure that you know what you're doing. Okay, so basically you are, assuring compiler that there is no loss of information, or I can deal with it. Okay, by casting it, you are actually indicating your willingness to cast the larger size to small size. Okay, the same thing here. We have x is double, y is int. So when you actually compute x and y, it still result into double. So now if you are trying to assign into int variable, you have to cast with int. Otherwise, it's going to be a problem. It's going to be a compiler error. Make sense? All right. Okay, so that is casting between the primitives. Now let's talk a little bit on casting object. We're going to actually deal with this one in a bit more detail when we cover Java inheritance. So instances of classes can also be cast instances of other classes with one restriction. So they should be related by inheritance, meaning one class must be a subclass of the other. Okay, so that's actually one rule. Okay, and then there is also implicit casting and explicit casting, depending on which direction you're going to. Between subclass to parent class or parent class to subclass. So depending on the direction between the two, you might have to do explicit casting, or implicit casting might be allowed. Okay. So casting object is analogous to converting primitive type. So casting object is analogous to casting primitive to larger type and things like that. So let's see an example of that in the following slide. So again, if you do the explicit casting, you are going to specify class name like this. Okay, so let's see an example. So suppose you have two class objects. So one is employee and the other one is a vice president. And vice president is also employee type. So in this case, vice president is a child class of employee class. Okay, so again, we haven't learned Java inheritance yet. Okay, so I am just I'm just kind of giving you the kind of big picture of it. So vice president type is a child class of employee class. So we created employee object like this, and we also created vice president object like this. Okay. Now, when you are assigning vice president type to employee type, that is implicit casting, and that is no problem because you are assigning vice president is always employee type, so there is no confusion. Okay. However, if you try to assign employee type object to vice president type object, there could be a possibility that employee object might not be in fact vice president. It could be the janitor or the president, right? Okay. So in that case, that's going to actually cause a compiler error. So again, when you are mapping the larger type to a more specific type, like a subtype, Java compiler wants to make sure that you know what you're doing. So, basically it's forcing you to provide the typecasting. Okay, so this is the explicit typecasting. We're going to actually do this exercise later on when we learn Java inheritance. Okay, so we're going to actually do exercise only on primitive type, exercise 1.1. Okay. So let me actually explain the exercise. I'm going to actually do a bit more presentation. Okay, so let's exercise 1.1. So in this case, this is between two primitive types. So we have int type and double type. Okay, so we are assigning int type to double type, and that's implicit casting, which is perfectly fine. This is another example of implicit casting example. Same example we have seen in the slide, and this is explicit casting example. So if you try to assign double type to int type without casting, that is going to be compiler error. Okay, so let me actually just open the project, import. So my casting primitive here. Okay, so for now we don't have a compiler error, but if I try to cast double type to int type without casting, then it's a compiler error. Type mismatch, cannot convert from double to int. Okay, so in the case you have to cast it. So for example, like int. Okay, and then it will take. All right. So the same thing with that. So you can actually modify it to actually oh yes, this is just to see the compiler. Okay, so this is, then you can actually fix it by explicit casting. Okay, so that's 1.1. So let me move on a little bit. Primitives and wrapper types. So we have seen examples of primitives, a byte, long, and int, and things like that. So, you know, in Java, every variable has to be declared with a type. So this is the reason why Java is called a statically typed language as opposed to dynamically typed language such as JavaScript. Okay. There are two kinds of types, primitive types and reference type. And reference type sometimes called the object type. Okay? So we have seen examples of both. So primitive type, like a small int, long, and things like that. Reference type, we have seen string class or the integer class. So those are examples of reference type or object type. Okay. Okay. So wrapper classes. What is a wrapper class? So the every primitive type has a corresponding wrapper type, meaning they have a corresponding the counterpart, which is a reference type. So this capital integer is a wrapper type. So it's a genuine object type of primitive int, and double primitive has a double wrapper type. Same thing for long. Okay. So basically, by using this wrapper type, you can create an object that holds the same value of corresponding primitive type. Okay. Now, why Java designers came up with the wrapper classes for these primitive types. The reason is this. The object class is the root class, right? So if you want to take advantage of methods of object class or properties of object class, you have to create you have to create a subclass from object. So only objects can access methods of this object class. So primitive types, because they are not objects, you cannot access the methods or properties of this object class. Okay, so that's one reason. Oops, sorry. Yeah, so that is, the first one is basically reason number one. You need object representation of these primitive type variables to take advantage of the properties and methods of this object class. Okay. Another reason is this, the collection. We haven't learned the concept of collection yet. Okay, so that's something we are going to cover on day 3 tomorrow. Collection is basically a backup object. Okay, so you cannot have a primitive type as an entry or an item in a collection. Okay, the reason is this. Sometimes you want to find out whether a particular item is filled up with a value or not, right? If you allow primitive type as an entry of collection, there is no way that you can check whether that entry is in fact filled or not. You cannot use 0 as a way of detecting whether that item is in fact filled or not, because 0 is a valid value as far as a primitive type is concerned. So by making the rule that every item in a collection has to be of object type, you can use what is called a null. Yeah, null means basically there's nothing, right? So by checking an item is null or not, you can see whether that item is in fact filled or not. So that's the second reason why there is a wrapper class for each primitive type. Okay, does that make sense? Question? All right, question. So let's see how we can convert primitive type to objects and vice versa. So we have already seen some of this. So here, if you want to create integer object, you're going to use a new keyword because integer is a genuine class, right? So here you are providing initial value, okay? If you want to convert integer object to int primitive type, then you are going to use int value method. Question for you, is this instance method or a static method? Give me an answer, please. Yeah, it is an instance method, right? Because you're dealing with an instance, okay? Now, this is an example of converting string object to int type, okay? So this is obviously a static method, okay? Because we are using the integer class directly, okay? All right, so there is a way that you can convert between primitive type to object and vice versa. Okay, that is exercise 2. So basically, it's the same code that we have seen in the slide. Okay, you might want to actually try long and boolean and things like that. Okay. Okay, so let me actually finish up the presentation. Then I'll give you guys a bigger chunk of lab time. Comparing objects. We have used this equal and not equal operators for comparing primitive values. And comparing primitive values with these things is kind of obvious. They are checking the values, right? Okay. However, when you are using these operators with the objects, the semantical behavior is different from the primitive value. So let me actually explain it. So when you are using equal with objects, it is not checking whether they have the same values. Instead, it's checking whether they are pointing to the same object instance in memory. So that's what this equal operator means when it is used with the object. Okay, and I'm going to give you an example using the following slide. And this not equal operator is indicating whether those two objects are pointing to the same the object in memory. Okay. All right. So let me talk about it using an example. So here we're going to actually use a string class. So we have created a string object using literal. Okay. So this is there has to be some memory somewhere that contains this value. Okay. That's a string object. And str1 is actually pointing to that memory location. Now we have assigned string 1 to string 2. Okay, so when we actually display string and string 2, it should actually display the same value. Now, when we compare this string 1 and string 2, they are pointing to in fact, the same memory location. So it should return true. Now, if we are creating another string object using string 1 value, basically it creates another memory location that contains the same contents, same string value. However, string 1 and string 2, they are in fact pointing to, hold a second. Let me explain this slide again. So in this case, we have, when you do this, string 1 equal free bound periodicals, whatever, basically we have a memory location that contains this string value. So now we actually assign string 1 to string 2 variable. So string 1 and string 2, they are actually pointing to the same memory location that contains this value. So when we compare string 1 and string 2 with this equal operator, it should return true. Okay. Okay, hold a second. Okay, so let me just explain this slide one more time. So in this slide, we basically have two string references variables, being variables. So the first one is assigned with a string object. So when we have this literal, the string object, there is some memory that contains this value, okay? And string 1 is pointing to that location. Now we assign string 1 to string 2 variable, and wait a second. Sorry about that. Yeah. So in this case, string 1 and string 2, they're actually pointing to the same memory location that contains the string value. So this should return true. Now, we created another string object. In this case, we're just using string 1's value as the initial value of the string object. Now, this one creates another string object someplace else. So the string object of this and string object of this string 2, they're actually pointing to two different locations. So when you try to compare string 1 and string 2, it should return false. Okay? Okay, so given that now, suppose we have hello and hello, both string object, the string literal assigned to string 1 and string 2. Now, this is a special. When you are using string literal like this, and if you create another one like this in the same code, Java is intelligent enough to know that you are actually using the same, you want to actually have the same value. So, it will actually pointing to, the string 2 will actually pointing to the initial instance of this hello string object. So in this case, when you compare string 1 and string 2, it will return true. Okay, so this is what I just said. String literals are optimized in Java. So if you create a string using a literal and then use another literal with the same characters, Java knows enough to give you the first string object instance. It's not going to create another one. Okay. However, if you try to create two string objects, even though they contain hello as the same string value, these guys are two different objects. They just happen to have the same values. Okay, so this string object and this string object, they are in fact, in different memory locations. So when you compare this string 1 and string 2, it should return false. Okay. All right, so that is the exercise 2. So let's take a look at the exercise 2 here. So here, basically, we are just exercising all those things. Okay, so we initialize the string 1, string 2, and basically you are just comparing this. Okay, and then we created string 2 with the string object, and this one should return true. Now, if you want to actually compare whether two string objects are in fact contain the same value, then you need to use what is called this equals. Okay, so remember we have learned equals ignore case, the instance method, right? There is an equals method that you can use to compare whether string 1 and string 2 contains in fact the same string value. So in this case, it should return true because they happen to actually contain the same values, right? So when you run the application, it should actually return the same, this result, okay? All right, so I'm gonna actually let you do exercise 1 and 2, okay? In the meantime, I'm gonna actually set my machine a bit. GetClass method and instanceof operator. So every object, if you want to find out what class is represented by that object, you can call the getClass method. Okay? So it will in fact return the class object instance. So there is in fact the class, and every class that is loaded into the memory is represented by this class object instance. Okay? And the class object, you can call getName method of it. So suppose I have an object, and I'm going to call getClass the method. It will return a class object representing the class of my object. And then I can call getName, and I should be able to get the actual class. Okay? Class name, basically. Instance of, check whether an object is instance of a particular type. By the way, when I say type in Java, I'm talking about the class or later on interface. So I can check whether Texas is instance of string class as should be true, right? Suppose I have created And point object, so there is a class called the point. Okay, so I created a point object by using new keyword. Okay, so I have a point object instance. Now I can check whether this point object is instance of the string. It should return false because it's not a type of string class. Okay. However, if I say point instance of point class, it should return true. Or I can even say point instance of object, because every class is a child class of object class. Point instance of object, that also should return true because a point is also a type of the object class. Again, we're going to talk about that Java class inheritance later on in detail. Okay, that is exercise 3. So let's take a look at the exercise 3. So here, when I call the getClass method, and for any object, it should return class object. Okay, so you can see the type of object is in fact class, right? Okay, then if I display the class, it will basically display this guy java.length string. Okay. By the way, whenever you actually provide an object, internal with the system of println, internally is going to call toString method. So every object can call toString method, just like every object can call getClass method, because getClass method and toString method, they are all from the object class. So let me actually show you what I mean by that. So this is the my getClass method. All right. I should be able to use any class. So, you know, suppose I actually take a look at the string object. Let me actually go to the Java documentation. And you can see string is a child class of object class. So if I go to object class, you can see some of the methods that are from the object class. So every single object should be able to call this method. Okay, so one of the method is a getClass method. It returns the runtime class of this object. Okay, and also the string, toString. So basically, it returns string representation of the object. Okay, so when you are calling, when you are providing an object instance and inside the system of println, internally it calls the toString method of string class. Okay, all right, so here and then if I want to get the name of that class, okay, so let's actually run this guy. Yeah, so basically we are basically calling toString method of the class object, so that is going to return this guy, class java.length string. If I want to just get the name of it, then I can call the getName method, and it's going to just return java.length string. Okay, and that is working with this, other objects. So in this case, we are actually trying with the integer as well. Okay, and it should work exactly the same. Okay. And then the next one is we are basically checking. You might want to actually try the Java util.date class and get the class information as well. And this one is checking whether the string 1 is instance of string, string 1 is instance of object. Both cases it should return true. Okay. In this case, int1 is instance of integer, should return true. Instance 1 is instance of object, that should return true as well. Integer is also a subclass of number. Okay, so let me actually show you. Again, we haven't learned the Java inheritance a bit yet, but you can see objects, the classes have inheritance relationship in this case. My instance operator. What is my instance operator? Oh, instance of, okay. So if you take a look at the, yeah, actually I should actually go to integer. If you go to Java documentation of integer, integer is a subclass of number class, and number class is a subclass of Java object class. Okay, so we have this hierarchy of the inheritance hierarchy between object class and number class and integer class. Okay, so when we actually call instance of in each of those, they all should return the true. Okay, but if you check the instance of is like instance of string, okay, and obviously this should return false. Oh, it's just a boolean. Incompatible conditional operand types, integer and string. It should provide two. Yeah, I should actually check that it should not be a compiler. Incompatible conditional operand types, integer and string. Yeah, okay, so I'm not sure why this is causing a compile error. Okay, it should just, you know, the int1 instance of string, so that should return, you know, just false. Okay, so I'll kind of spend some time figuring what is going on with this particular statement. Okay, so I'll give you guys like 5 minutes to do this exercise. And also let's have about 20 minutes lunch time as well. So let's get back in 25 minutes. So, you know, right now it's 20 minutes after 12. So let's get back 12:45.